This week we will talk about how we can read and write to different kind of files. And we will start with simple text files. And to read from a text file and also write to a text file, we have to open that file. And so you write open, then the name of the file as a string. On the left we can see here we have the file text file. We pass that as an argument. And then we also have to specify the purpose of why we open the file. So for reading or for writing. And this can be done by either typing R for reading or W for writing. If we're unsure about whether we want to read or write, we can also type R+, which indicates that we want to read but also write. And this open function will then return a file object to us, which we can store in some variable. And to now read from this file, we can write f.read and then store what is returned in some variable. Let's call that content. And then we can print this content. And this gives us this output here. And if we now check our actual text file, we see that it's equivalent. While this syntax looks very simple, it's not the best practice, because we're missing one important operation, namely the closing of the file, which we can do with f.close. If we're just playing around writing a few things to our files, then this closing is usually not that important, because Python will take care of that. And also, as soon as we assign the variable to something else, it will also close the file. But in general, it's really good practice and really important to close our files. And so because the f.close is something we would have to write every time, Python offers a shorter syntax for that. And the syntax that we will use is also called a context manager. And so we write with, and then we copy the open function, and then we open our text file as some variable. We can also call that f. Then we write a colon, and then in the next line we can do stuff with our f. For example, read its content and then print it. And so these two code blocks are equivalent in terms of their functionality. And now to explain this syntax here a little bit, we can print the methods that are available for the file object that is returned by the open function. So we'll print dir f, and let's comment that part out. And then we see the dunder methods enter and exit. And these methods allow us to use the file object as a context manager. So they define what happens when we start using our file, or when we enter, and also when we're done or when we exit. And so you can imagine in this codebook here, we do something to the file, and beforehand we call the enter, and after that the exit method. And in this exit method, the file will be automatically closed. So to summarize, we can think of the file that we get through the open function, not just as a file, but also as a context manager that adds context to whatever we're doing with the file before and also after that. Okay, what else can we do besides just reading the file? One other method that the file object provides is read lines. And this gives us all the lines in a list. And what's interesting is that the new line character is also part of the respective lines. Just like we read multiple lines, we can also read a single line. So this gives us the first line of our text file. What's important is that when we read something from a file, we move through that file. And that means for the next read operation, we don't start at the beginning, but we start where we left off in the previous operation. So when we read two lines separately, it gives us the first and then the second line, and not two times the first line. What can help us navigate through our file are the functions seek and tell. The function tell will tell us where we are in the file currently. So if we run f.tell, it will tell us that we are at character 20. And using f.seek, we can jump to any other character. So for example, the first one. And that now means that readline starts again at the beginning. So we get the first line two times. We can also give arguments to the read functions. So for the read line, we can give an argument that indicates how many characters we want from that line. So if we write 10, then we just get the first 10 characters. The same works for read. So without any arguments, read gave us the whole text file. And if you write 10, then it just gives us the 10 first characters. We can also use for loops to iterate through our file. So we write for line in f. So just f, and then we can print the line. And right now the end argument of our print function will add a new line after each print statement. So we can set the end equal to just an empty string. And now we get, as expected, our whole text file. Okay, that's it for reading from a text file. Let's move on to writing. And so we copy this whole line here, and let's comment that out. And to write in a text file, we simply write, instead of read, write, and we can pass it some string. So let's say new line, and then if we run that and then check our text file, we'll see we added in the beginning new line. And maybe that's not the behavior you expected. Maybe you thought it would add the new line at the end. And for that to happen, we change our mode. So instead of having R+, which includes the writing, we switch to A, which stands for append. So let's first revert our changes here. And if we now run our code, then we see now the new line is at the end. And maybe that's still not what we wanted, since it's right next to line 6, but we can fix that by just adding a new line character. So let's remove that, run the code again, and then we have it in a new line. Okay, let's do something a little bit more interesting. And what we will do is that we copy this text file here. And so for that we have to create a new file first. And for that we just open a file that does not exist yet. So we write here new text file.txt, which is not in our folder yet. But if we open or create that file and then write to it, we'll see here the new text file pops up, and that contains the new line. And it's in the second line because we didn't remove the new line character here. So now it's in the first line. Okay, so let's delete that file again. And then we'll try copying the original text file. So we first open the original one, then we open the new file. So now we have two context managers, one that opens the original file and we'll only use that for reading. And then we open inside of that our new file, and here we will append the lines. And of course we have to give the file objects different names. So let's call that file OG and that file new. And then we iterate through the lines of the original file, and instead of printing the lines, we write them into a new file. So fnew.write, and we write the line. And if we run that, then we now have a copy of our file. And this in itself is of course not really useful, but we could also, for example, make the line uppercase. So we write upper. And now our new file only contains capital letters. Okay, finally a small note on opening files which are not text files. So for example, we have this cat image here, and we can try opening that. So we write cat.jpg, and we open it just as f. And then we can try f.read and print that. And this tells us UTF-8 codec can't decode byte. And that's because, of course, our cat image doesn't contain text. And so for these cases, we can add a B standing for binary. And this B now allows us to also read from binary files. So if we run the code, we see all these bytes here, which we of course cannot read. And you might also be wondering why this binary file is not all zeros and ones. And that's because writing zeros and ones would make the output very, very long. And so our editor chooses some kind of encoding. So because we're not using the binary system, we can display more information in less space.